Hello everyone. So today we're going to go through the third part of this chapter, factorising, and let's get started with example 6. So we've got to factorise completely. So let's first make sense of what factorising is. It's basically the opposite of expanding, and we've done that in the previous two videos, so please check that out if you're having any trouble with expanding any of those expressions. Yeah, so let's start with our first example here. 3x plus 9. So in order to factorize, we have to see if there is any common factors between 3x and 9. And by a factor, I mean, so for example, 9 is 3 times 3, right? So the common factor here, because it appears here and there, the common factor here is 3. So, and I open my bracket. And in order to retrieve the 3x, what should 3 be multiplied by? It should be multiplied by x, right? So I would retrieve here x, 3x, and then 3 times 3, okay, because there is a plus sign, so I add 3 here. So if we were to expand this one, I would get 3x plus 9. So that's what I mean by factorizing is the opposite of expanding. So I'll do the same thing here. So what is the common factor? Is x. So I'll open my bracket. So x times x, it gives us x squared. And then x times 5, or rather minus 5, it gives us minus 5x. So again, you can retrieve the expression to double check. When you expand this, you will get this. I'll move on to the next one. So first, I will focus on the numbers. So what is the common factor between 8 and 20? So the highest common factor. Indeed, it is the number 4. So I'd write my number here, 4. What about the x's? There's x squared and x. So the highest power that's in common is x. So it's 4x. Then I open my bracket. So in order to retrieve 8x squared, in terms of the numbers, 8 is 4 times 2. So I would write 2. For the x, because it's an x squared, I'd write x. What about 20x? Okay, for the numbers, is 4 times 5. 20 is 4 times 5, so it's plus 5. Because I have a plus sign here, I'd write 5 plus 5 over there. What about the x? So, because x appears here only once, so I would close my bracket and leave it as 5, because 4x times 5 is 20x. So I had already retrieved my 20x. So always work with the concept of expansion in mind. That's how it works. So, because it's an equality, it should be equal to the same thing if you go from the other way around. Here again, so I'll focus on the numbers first. The common factor between 9 and 15, the highest one is 3. 9 is 3 times 3, and 15 is 5 times 3. Moving on to x, the highest one is x. Moving on to y, between y and y squared, the highest is y. So now I'd have to retrieve my 9x squared y. I'll focus on that first. In terms of number, 9 is 3 times 3, so I've already retrieved that. In terms of x, because we have x squared, we'd write x. For y, there is no y, because it's only y, and y times 1 is y. So I'll do the same thing for the next term, which is 15xy squared. In terms of numbers is 5. In terms of x, I wouldn't write x because it already appears here. And y squared, we would be left with a y. So plus 5y. And always remember to not mess it up with the sign here, because we have plus is plus 5y. And we're done with that one. So moving on to the next one. 3x squared minus 9xy. In terms of numbers, the common factor is 3. In terms of letters, in terms of x specifically, the common factor is x, is the highest power of x that's in common. And for y, it only appears here, so no need to include it. So I'll open my bracket. To retrieve 3x squared, I'd write x here. because 3x times x is 3x squared. For the sign again, I'd write minus 3. Okay, so I would have retrieved my minus 9. For x, I wouldn't write it because it already appears here. For the y, I would write it here. Okay, so you can see if you would expand this, this is 3x squared minus 9xy. Perfect. So now that we're done with example 6, let's move on with example 7. But before I go on to doing it, I would want to talk to you briefly about what it means to have a quadratic expression. So quadratic expression is anything that's been written in this form over here. So a and b and c could be any real numbers. It could be 1, 2, root of 3, 1 over 2, any number. But with the condition that a is different than 0. Why this condition though? Is because if a is not different, is 0, we would simply have something in this form, which is a linear expression. So it would lose the name basically. So in this case, this is a quadratic expression. This is yes, this is no, if that makes sense. So a quadratic expression is an expression where the highest power of x is 2, as seen in these two examples. Okay, now we'll have to factorize. So how to factorize, when you encounter these kind of expressions, there's a specific way to factorize them. And what it is first. So let me identify my a and b and c in this expression. My a is 1, my b is minus 5, and my c is minus 6. So I'll write them here. A is 1, b is minus 5, and c minus 6. So I'm just like making like this kind of, you know, so so first of all, I would find my AC. So I'll multiply that. A times C, 1 times minus 6. Okay. And B is minus 5, so it remains as it is. Okay. So I need to find two numbers. You know, if you multiply them together, it gives you minus 6. And if you add them together, it gives you minus 5. So think in your mind, what are these two numbers? So I always, whenever I encounter these questions, I like to think of two numbers that multiply, and then when I find that combo, I check which ones add up to minus 5, for example. So I can think of two numbers, easy, 2 times 3, and because we have this sign, it should be minus 2 times 3 or minus 3 times 2. So let me check if they actually if they add up to minus 5. 3 minus 2 is 1, and even if you will to flip the sign, it's gonna give you just the opposite. So minus 3 plus 2 is minus 1. So this is not the one that we're looking for. Let me check another combo. So I can think of minus 6 times 1. Okay, so minus 6 and 1. So if we were to add them together, indeed, it will give us my b, which is minus 5. So these are the chosen ones, basically. So this is a pre-step. Before you go on to solving it, if you get this, you will get everything right eventually. So now I know that I have to split my minus 5x as minus 6x plus x. You can see this is the same thing. Minus 5x is the same as this sum over here. So let me write it in a way that I'd be able to factorize. Okay, so I would write x squared plus x. So I'm just flipping the order. Minus 6x minus 6. So this is, as you can see, is minus 5x. Okay, so we're going to do what we've been doing in example 6. A common factor here is x, and we're going to get x plus 1. Here a common factor is minus 6. So minus 6 times x is minus 6, so we retrieved it. And minus 6 times 1, so plus 1. You see? So it all works out. So the reason why we've done that initial reasoning here is to come to this stage and find a common factor, which is a full expression here, which is x plus 1. So this is the reason why we did all of this kind of brainstorming, whatever. So my common factor here between these two is x plus 1. Okay, and then I'm left with x here minus 6. And that sums up, the working out for this question. Um, well, in the case where um, it is the question is about factorizing, it's necessary to go through all of these steps. But when in the case where factorizing is just part of solving, you can easily do it directly. You do x plus 1 and minus 6 here when a is 1. When a is 1 and you have these kind of expressions and you find out that your factors are 1 and minus 6, so you just deduce that it's written like this, x plus 1 times x minus 6. I don't know if it makes sense, but later on other stages where factorization is not the final, is what you're being assessed on, um, it's easy to use this shortcut, if that makes sense. I don't know how to explain it, but yeah. Um, so here, we're gonna do the same thing. So I'm gonna identify my A. A is 1, B is 6, and C is 8. So A times C is 8, and B is 6, as you can see here. So I'm gonna highlight these, because these are the ones that I'm actually interested on. And this is the one that actually gave it out for me. So yeah. So let me think of two numbers that um add up to 6, and when you multiply them it gives you 8. So easy, easy way to find. I can think of 4 times 2. You don't have to go through every step, every like combination to get there. Sometimes you get on it from the first try. So this one is an easy one. 4 times 2. So 4 and 2. So using the shortcut I used earlier, I told you earlier, I know that's gonna be x plus 4, x plus 2 times x. This is how it's factorized, but here we need to learn how to do it. So um this is gonna be x squared plus 2x plus 4x. So I'm just, you know, separating this one into these two, okay? And I'm gonna have, oh yeah, plus 8. And then I'm gonna factorize these two together and these two together, like we've done in example 6. A common factor is x plus 2, plus here, a common factor is 4, between 4 and 8, and I'm gonna write x plus 2. So yeah, I'm getting x plus 2 over here, and x plus 4. And as you can see, we've got what I've told you earlier. But yeah, don't do this at this stage. Yeah. So before that, I'm gonna remind you of this identity, um, which is the difference of squared. So if we come across these expressions, there is a shortcut to factorize it. So just keep it in mind. You can use it directly in your exams. A minus B is factorized to A minus B, and then A plus B. And A and B could be a number, it could be like a combination between a number and a letter. For example, it could be like 2x or 4xy or something like that. It could be anything. So let's get through these first examples. So I'm gonna do again A equal to 6, B is equal to minus 11, and C is equal to minus 10. And here we have AC is equal to minus 60. Quite a big number, but don't worry. So this is my AC, this is my B. So we've got to find two numbers that actually, when you multiply them together, it gives you minus 60, and when you add them together, it gives you minus 11. So I can think of a couple. I can think of minus 4. So I'm gonna focus on the product first. So how can we do this? Maybe minus 4 times 15 or minus 2 times 30, and now let's assess which one works in our case. So 2 times 30 minus 2 times 30 gives you minus 60, but when it comes to adding them together, it fails miserably. It gives you 28 or minus 28 if we flip the sign. But our lovely minus 4 times 15, it does, um, you know, it is approved in terms of the tests when you add them together. So 15 minus 4 does fail, but 4 minus 15, it gives you the right answer. So this can basically be rewritten as plus 4x minus 15x. Okay, so we're just literally rewriting it. And the whole brainstorming stuff is just to get to a stage where it actually factorizes. So I'm gonna rewrite this 6x squared plus 4x minus 15x minus 10, and then we're gonna factorize by the common factor here between 6 and 4. The highest one is 2, and between the x's is x. So we have 3x, right, plus 2, because 2 times 2x is 4x. Then here we would have minus, the highest factor between minus 15 and minus 10 is gonna be minus 5. Then 2, 3x plus 2. You see, minus 5 times 3x is minus 15x. If you multiply minus 5 times 2, it gives you 10, minus 10. So here, the common factor between these two is 3x plus 2. And then you're left with 2x minus 5. And here you have it. See, I told you it's simple. It just, instead of having x, you have 3x, whatever, but it's the same thing, right? So this next one, ding ding ding, what does it remind you of? If the expression I've just shown you here. So we're gonna use it, but we have to identify here what is x and what is a, what is b. So let me rewrite this. So 25, it's the square of 5, right? So now I know my a here is, in this case, a is x and b is 5. So think of them as this way. So x minus 5, x plus 5. You see? It's very simple. So here, we're going to do the same thing, but what you can see is that 4 is a square and 9 is a square. So we can indeed use this one again. But in this case, a is 2x and b is 3y. A disclaimer, this only works when there is a minus. So a squared minus b squared. You can't use it when a squared is added to b squared. Okay? Don't do that mistake. It's very silly. It's a very silly one. So this one is 2x squared. So I'm just writing it so you can clearly see it. This is a square, right? And now I can use the formula where 2x is my a and 3y is my b. And I get this. Perfecto. Okay, moving on to example 8, where we have to factorize completely. So first of all, it is not a quadratic expression, but we can factorize it the simple way. There is no, you don't have to think too much. It might not be as tricky as you think it might be. So, the common factor between these two is x squared, okay, and then x minus 2. See? Very simple. The second one, so the common factor between these two is x. Okay, so I'd have x squared on this side, then minus 25. Okay, So what is x squared minus 25? We've just done it here, so no need to go through these steps, but in a real exam situation, you would go through them. And you have x minus 5. I'm just going to copy from here. From the previous question, I know that this is equal to this, and I'm done. Perfect. Let's move on to the next one. The highest common factor is x squared between the two. And then I'd have x here minus 3. Oh, I think the way this is I did copy this example in a wrong way. So we're missing a minus 10x. I don't know where was my mind when I was copying this one. Yeah. Minus 10x. Okay, this is the example because I was thinking where is the challenge here? It should be belonging to example 6, but now I realized it's my mistake, my bad. So we can, there's the common factor here, which is x, and x squared plus 3x minus 10. Okay, so this is, as you can see, is a quadratic expression. So we'll apply the knowledge we've learned so far. My a is 1, my b is 3, and my c is minus 10. Okay, AC is minus 10. I'll highlight those we are having business with. So two numbers that you multiply together and it gives you a minus 10. I can think of minus 5 times 2. What about adding them together? Minus 5 plus 2 is minus 3. Maybe the opposite will work. So I will do minus plus 5x minus 2x. Indeed. Actually, it's not this. It's like the 3x over here that gives you 5x minus 2x. Okay. x squared plus 5x minus 2x minus 10. Just have it up here. That have more space. And then x, because it makes more sense to have this one go with this one because they share a common factor, and join minus 2x with this one. So yeah, you would have to make that choice. I mean, with experience, you would be able to tell because which factor goes with which factor goes with which factor, and it's not the same. So you can't factorize this and that one. You know, the main idea is to get to a point where a factor appears on the right hand side and the left hand side. If you don't get it to that stage, like for example here, then maybe you have to flip the factors. Okay, so yeah, so x minus 2, and then plus 5. 5 is the common factor, x minus 2. So here we successfully got the common factor in both of them, and then we get x minus 2, x plus 5, and perfect. We're done with today's lesson. I shall see you in the next one where I'll be going through some of the exercises which might be a bit more challenging than these. And yeah, I shall see you next time. Bye.